Welcome to Statics Lectures by Civil Thinking, and today we are going to solve another problem on force systems. Today we will solve a problem on movement due to forces and couples. Now before I move on, I suggest you to please watch my video lectures in sequence as in the playlists for better understanding. I will provide the link in the description to the playlist, or you can also click here. Now coming to the question, a 100 centimeter meter rule is pivoted at the middle point. Okay, now we have a scale, meter rule. You might have seen this in school or college. Now it is pivoted at the middle point, 50 centimeter point. Okay, we have a 100 centimeter scale. Let me draw it first. Let me draw it here. Now here the reading is 0, right? And here the reading is 100 centimeter, right? Now it is pivoted at the midpoint. Let me assume the midpoint is somewhere here. Okay, here it is 50 centimeter. It is pivoted here, means it is supported by something at 50 centimeter mark. Now if the weight of 10 Newton is hung from the 30 centimeter mark, now there will be somewhere 30 centimeter will be around here, 30 centimeter. Okay, now we have a weight of 10 Newton. Okay, at this point, a weight of 10 Newton. It is 10 Newton here, and a weight of 20 Newton is hung from it is 60 centimeter mark. Now here is 50 centimeter, here is 50 centimeter, and somewhere here will be 60 centimeter. Now here is a weight of 20 Newton, right? 20 Newton is here. Now we have to check if this scale will remain balanced, will rotate clockwise, or will rotate anti-clockwise. No. Okay, now let us assume this is the point C. Okay, this is the point C. If the movement at point C is 0, if the summation of movement at point C is 0, okay, it will be in static equilibrium. Okay, static equilibrium. What does that mean? Static equilibrium means if a body will not move, okay, if it is static, it will not rotate. Now if you want to know more about static equilibrium, please watch my video lecture on static equilibrium. Okay, now if the net movement at point C is 0, then it will be in static equilibrium or balanced. Okay, it is also, we can also say it is balanced. All right, now let's find the movement at C, and we will see whether it is 0 or not. If it is not 0, so it will rotate. If it is 0, it will not rotate. So movement at C will be due to the force 10 Newton. Okay, now the 10 Newton will exert movement like this, which is anti-clockwise movement at C. So I will use the negative sign, because you remember the sign convention. We can choose negative sign for the anti-clockwise movement and the positive sign for the clockwise movement, or vice versa. I am choosing negative for the anti-clockwise. Okay, so minus 10 multiplied by, how much is 10 Newton far from C? Now here is 30 centimeter mark, here is 50 centimeter, so it is obviously 50 from here to here is how much? 50 minus 30 is 20 centimeter, right? So it is 20. Okay, now due to 20 Newton, what is the movement at C? Due to 20 Newton, now due to 20 Newton, movement will be clockwise, so it will be positive, plus 20 Newton multiplied by, now how far is 20 Newton from C? Now this is 50 centimeter mark and this is 60 centimeter mark, so the length, this length or the distance between them is 60 centimeter minus 50 centimeter, which is 10 centimeter. Okay, 10. Now this is 20 multiplied by 10 is 200, and negative sign, it is minus 200. Now 20 multiplied by 10 is 200 and with a positive sign, right? Now how much is minus 200 plus 200? It is 0, right? This is what? This is summation of moment about C, right? This is the total moment. Summation means sum of all the moments. Okay, because we found the moment of 10 Newton at C, then we added it to the moment by 20 Newton at C, so it is summation. Okay, this sign is for summation. Now we get the summation of moment at C to be 0. What does that mean? It means this meter rule, is in static equilibrium or balancer, which means which option is correct option? Option A is correct, will remain balancer, right? So that's it. This is how we solve this problem. Now if you have any doubts, please comment. See you in the next class. Thank you.